Hello, ladies and gentlemen. Welcome to the DPLA channel. Today we're once again at Shapetov's workshop and we'll see how the machine's assembly went. So, shall we get started? So here's everyone's favorite Mikhail. Tell us, what happened here over the past week?
Greetings to everyone. Over the past week, we assembled and adjusted the entire machine. Well, actually, just the cross slide because we had previously aligned everything else together on a granite plate. We'll show the results. As a reminder, we measured the rigidity for clarity and did it quickly, since we only removed the mounting and alignment fixtures today. We did it in the morning because the glue took a long time to set, and we decided not to risk the machine shifting or moving. Many people didn't understand what the spindle head would look like and what this thing here is. It's simply just a piece of metal to keep the carriage from slipping off, purely for safety reasons. The spindle head itself will look approximately like this. Here there will be a motor, and next to it, the spindle and the special gearbox. It will appear in about a month and a half, but for now this is its mock-up. It moves on 4 carriages, 1, 2, 3, 4, and there's one support at the back. Accordingly, the screw is located right here. Here, the spindle is positioned in the plane where the supports are attached. It hasn't even been moved out. How precisely did we actually align it? We used an indicator and a granite surface plate, class 2-0, just a regular Chinese one. Let me shake the indicator now to show you that it's working. That it's not jammed, that it's fully functional. We can check that. But as for the machine itself, I hit it and it stands on its own. It doesn't have any supports, meaning the lower part of the frame. It's still in the design phase. It's standing on wooden blocks and boxes. And it's tied to them so it doesn't tip over. We carefully loaded the vertical axis with a total weight of 60 kilograms. However, the indicator does not react or respond at all, showing absolutely no movement. In principle, we can also try to load it on camera. If it's visible, that is. So, that's a total of 20 kilograms we've put on so far. And now here's another 20 for you. There we go.
That's heavy.
Now we'll add another 16 kilograms to the total weight. And another 20. We've weighed a lot here before, but now we're putting on even more.
You hit it and it got knocked off a little bit.
But it stayed in the opposite direction. And another 10. So now we'll have 20, 40, 60 kilos here. 76, 81. And I think that's 6 kilograms. Therefore, 87 kilograms in total altogether.
We need to buy some weights.
Yeah, I can take it off and check the indicator. It should stay in place.
Now try to slowly move it towards yourself, gently. Absolutely amazing. This, ladies and gentlemen, is without a doubt all the way through right to the very end now.
Yes, but here it actually has a little bit of play, about 10 millimeters, so that the shoes don't slip off. For now, we're not doing it that way. Overall, it's level, but it's on wooden supports, which provide a stable base. We're going to design the lower part now, in order to create a proper workspace. Actually, the spindle should be positioned higher, roughly at chest level for a person. The spindle center will be higher, and right now it's planned primarily as a honing and boring machine. A bit later, we'll start making a milling head for it, which will expand its capabilities. We'll increase its travel to 300 millimeters, so the cross-section will change and it'll get bigger. The concept will stay the same, but will increase the longitudinal travel to 300 millimeters. Right now it's 860 millimeters, and that will stay the same. For those who are especially interested, some guys are asking about a replacement for the Rottler for boring large locomotive blocks and similar things. Basically, you can get that from this same machine, we just need to lengthen the bed. The spindle overhang axis, thanks to this particular configuration, fits in very easily, just like it does on the Rottler machine. We're making a slight modification to the bed, since the spindle cut is basically aligned with the current top edge of the bed. Well, the very top of the bed, the spindle axis, the spindle cut is located right on it, exactly in line. We can work around that issue and install huge heavy engine blocks right here in this area without any significant problems. We carefully glue in the base surfaces, which are the foundational pieces, and then we use these to securely bolt on the supports as well as the screws. Can you show?
And you can see it right here, right?
There's really no base here at all. We just glued this support on. The first casting had an 8mm error, so it was easier for us to do it this way. But on all the others, the base surfaces will already be glued in. For example, you can see it right here. Here it is, the base surface. It's glued in place. And the support is screwed on through it. In other words, this particular method significantly increases our overall accuracy because milling with high precision and attention to detail, from one side it's not a problem, but from another perspective, it's very hard to control yourself, especially since some of our supports are like this and others are like that, which adds complexity. We potentially have a reference point, but it's generally faster, clearer, and more reliable to adjust using the lines as guides. And if we see somewhere that there's 1/100th of a millimeter deviation, it could have been better, but we're also coming up with the adjustment tooling as we go, making improvements along the way. It's not perfect yet, let's put it that way. There's still work to be done, as you might expect. As for the glue, we bought it from a company called Epitol. It's an equivalent to the European Secador 31, or you can check the name if you are unsure. The glue is truly excellent. It's extremely strong. We tried to tear it off and it actually rips a chunk of concrete off the metal if the surface isn't oily at all. You can only remove it with a grinder, even if you try with a spatula. Only a grinder can grind it off completely. That's already being prepared for the next stage, which will follow soon. For proper alignment, we carefully painted the specific spots where the adapter plates will eventually be glued in place. At these marked locations, holes will be drilled and then threads will be cut here, here, and also here. Into this particular one, we will glue the housing that is designed for the rotating nut. After completing that step, we'll proceed to clean the wedge. Although it's not very convenient or easy to do, as we continue working, we're gradually getting better and better at it. If we run it in, just like this, smoothly along its guides in both planes, we then fix this mandrel in place. It's extremely precise for us. And glue in the housing. The nut itself has already been made, and the nut bearing for the ball screw is actually made from a gazelle wheel hub bearing. We have to remove the dirt deflector from it because otherwise it has too much inertia and the friction is excessively high. The clearance is about 1/10 of a millimeter in diameter, but even so it's still much better than just leaving it open and exposed. Another bed is also ready at this stage. The ball screw is currently prepared with its extensions, the guides are precisely aligned, and the carriage is also ready for use. The vertical axis is here as well. These are specifically the spots for the embedded parts and also the spots for the embedded pads. We'll glue them in the same way as before. Align, glue, drill, tap threads, and so on, following the same process as previously described. As for the spindles themselves, we ran into some difficulties with them. I can tell you a bit about that. Because we want to achieve high compactness for the honing machine, let's take it and remove this spindle. For high compactness, the honing machine needs to be able to accommodate the main drive motor, the drive motor for the stroking mechanism, and the honing mode itself. And we want to use a rotating nut without extending the ball screw, which is important for maintaining a compact design. There are options where the lead screw extends, but then it ends up being too tall overall. We do not want to limit the ceiling height for people who might be working on it. That's why our vertical axis drive motor will also be located here. Because of this, the compactness is extreme, and we want the spindle axis to be in the plane of the bogies. The compactness here is truly extreme. The original dimensions of the unit were not very large to begin with, but literally just this morning, yes, we carefully assembled a compact spindle unit for the honing machine. We fit everything in, found the necessary gearboxes. The milling spindle will be made in the same way, only it will be twice as long. It will have another bogie added at the back, so there will be 6 in total. The rail is 20, small, but there are 6 bogies. It will be longer. On the milling machine, travel will also be around 400 millimeters. Right now it's 740 millimeters edge to edge. The working area is 700 millimeters for the honing machine. That's from this kind of setup. And during the process, when we were designing the head, we had to redo the upper support plate of the lead screw. There were some nuances, but we solved those issues literally today. That's about it.
What are our next steps?
The next steps. We'll cast the spindle heads for the milling machine and for the honing machine. we will steam them simply to speed up the process. We'll cast them, steam them, and cast the bed as well, letting it cool naturally under the right temperature and humidity conditions. And then we'll start testing and running the program for the honing machine, while on that bed we'll be testing everything else for the milling machine, for the CNC machine. That's the plan, and people are also asking for a third bed, specifically a lighter version of the bed. We'll carefully think about how to make a lighter bed without overcomplicating things or making the process unnecessarily complex. This is because we have 3 sets of vertical axes and 2 axis carriages. Because there are 2 beds, but we have almost 3 sets of machine parts. That's the plan.
And as I understand it, we also need to come up with some kind of stand for it.
So we'll have to carefully figure out how to arrange the legs so that the whole thing looks visually cohesive and unified. It doesn't seem like a particularly difficult or challenging task, but there are definitely some subtle nuances to consider. I think we'll be able to sort it out within a month and then proceed to cast it. The reason is, since we're set up this way, we're essentially forced to mount the granite plate onto our own rails, because otherwise the whole machine bends and the granite plate simply can't stand on a separate surface. This caused a lot of issues with the tooling in the assembly process. Well, that's where we are right now, and we'll keep working on it step by step.
So, ladies and gentlemen, I hope you enjoyed it. Feel free to ask questions. Mikhail will answer them. Subscribe to the channel and give us a like. All the best. See you soon.
Tell them to join us on Telegram.
All right, folks, and subscribe to our Telegram channel as well. The link is in the description. Mikhail responds quickly there if anyone is interested. All the best.